this is the function. That's where the particle is, or whatever, something is moving there, or we simply want to find the point on this curve that is the closest to this point. Well, by closest, we really mean minimum distance. So let's picture the idea here. We know how to graph the square root of x. That's embedded in our memory. So this is y equals the square root of x. The point 3 comma 0, let's say it's here. And there is a point on this curve, on this function. It doesn't matter where you plot it. The result will give us exactly where it is. Okay? So I'm just going to say that this is the point. I'm going to call this point a comma the square root of a, because if it is on the function, it has to verify the equation. So when x is a, y is the square root of a. I am going to draw, so this is 3 comma 0. I am going to draw the distance between the 2 points. And I'm not going to call the distance d, because I don't want, when we differentiate, to say dd, right? Or d prime. I prefer any other letter. So let's use w. So w is the distance between this point and this point. Anyone remembers the distance formula? x2 minus x1 everything squared plus y2 minus y1 everything squared. Okay, so what are these? x1, y1, x2, y2, or vice versa. It doesn't matter how you order them. But x1, y1, x2, y2. So then I will plug them in. x2, a minus 3, or 3 minus a, it doesn't matter. But we have to be consistent, although it doesn't matter because they're squared anyway. So let's say a minus 3 plus the square root of a minus 0 squared. We square. Can anyone give us how much is a minus 3 everything squared? Anyone would like to square a minus 3?
Yeah, a squared minus 6a plus 9.
Thank you very much. Awesome. So a squared minus 6a plus 9 and plus a. So w is the square root of a squared minus 5a plus 9. I can say that this is w of a function of a. Good. I'm asked to find the minimum. I don't know if it's a minimum. We'll see. I have to convince myself that it's a minimum. But I'm not there yet. So how do I find the minimum of a function? What is the first step?
To find the critical value of numbers.
Very good. So I have to find w prime of a. Can anyone differentiate this function for us? Anyone?
1/2 times quantity a squared minus 5a plus 9 to the negative 1/2, or yeah, whatever, and then times 2a minus 5.
Very good. Awesome. So we know that w prime of a could be 0, or w prime of a could be undefined. This cannot be undefined. This cannot be 0 because then the function is 0. So that's not possible. And when a fraction is 0, what can happen? A fraction is 0 only when
The numerator is equal to 0.
Very good. So we have 2a minus 5 equals 0, or a equals 5 halves. Do I know that this gives a minimum? Oh, no. Oh, no. I have to prove that. So here's our proof, or proving it. A, 0, 5 halves, w prime of a, 0, w of a. So this is positive because it's a square root. So only in the numerator, I would plug in 0 to find the sign here, and I would plug in 10 to find the sign here. We do not plug, this 0 is in the table, but we don't plug anything else. We don't put anything else in the table. So when you plug in 0, what would be the sign?
Minus or negative.
Very good. And on the other side, positive. Now this is guaranteed to be a minimum. And now I can determine the distance if I want to. Why not? So let's determine the distance. I don't think they're asking us to determine the distance. They're only asking us to find the point. So we found that A, so the point, let's write the point, and then we'll find the minimum. Right here. This will be the minimum distance. So the point will be A is 5 halves, comma, the square root of 5 halves. This is the point that is the closest to the point 3, 0. Guaranteed. I checked. I checked the sign. So now in order to determine this, in the function, I have to plug in 5 halves. And of course, I'm not going to do this by hand. I'm going to share my screen and put in the function. Yes, I know. Thank you. Okay, the square root of x squared minus 5x and then plus 9. And I want to plug in 2.5 or 5 halves. Just give me the minimum distance. So the minimum distance, let's say 3 decimal digits, 1.658. I know they're not asking for it, but who knows? We may be asked. So the minimum distance is 1.658 units. How do you feel about this problem? Is this better? Does it give us a little bit more understanding of how optimization, min-max, that's all it means, min-max. Anyone? Would you like to share anything? Any questions on this? I would say that they are easier than related rates, but it depends on the problem. So let's work on the discussion, so I don't forget that. We will have way more problems, and I also had a question. I was on a Newton's method. I think I copied it here, but I don't know where I copied it. I got it. It's natural log x equals 1 over x minus 3. So we'll do that after the discussion. So which rational functions have slant asymptotes? So for question number 1, slant asymptotes require degree n plus 1 and degree n, which means the numerator has the degree exactly by 1 unit larger than the degree of the denominator. 1 unit larger or higher degree than the denominator. For question number 2, which theorem we use to identify the 1 unit interval is the IVT, intermediate value theorem. And the last question was finding the limit. So limit as x approaches pi over 2 from e to negative x over pi over 2 minus arc tangent x. Okay, so the initial estimate, was it e to negative x? I think I messed up something. Of course, I copied it from the book. Let me see. I may have... I did mess it up, so I have to remove it. I copied it from the book, but here was my mistake. It was x approaches infinity. So I can't grade that. So I will remove it. So it's x approaches infinity. It makes no sense. I copied x approaches pi over 2. So it was problem 40 on page 317. So sorry about that. I copied incorrectly here. X approaches infinity. That's why it didn't make any sense. So since I put it up here, let me finish it. But of course I will remove it and give you all 5 points for free. That's what happens. Okay, so when x approaches infinity, the numerator goes to 0. The denominator also goes to 0 because we know that arctangent, when x approaches infinity, arctangent approaches pi over 2. Pi over 2 minus pi over 2 is 0. Yay! Because it's L'Hopital's rule. So then I have limit as x approaches infinity. E to negative x will be negative e to negative x when we differentiate it. And when we differentiate pi over 2, we get 0, and the negative stays in front. And arctangent prime is 1 over 1 plus x squared. Of course, these two go away. So I have again limit as x approaches infinity, e to negative x over 1 plus x squared. We have to work on this a little bit, meaning we have to rearrange it. So limit as x approaches infinity, I bring this down and bring this up. Because when we divide by a fraction, we basically multiply by the multiplicative inverse, and then I have to change this into 1 over. So the function becomes this. So e to negative x from the numerator goes to the denominator as 1 over e to x. And this, we are dividing by a fraction, so it's 1 plus x squared over 1. Only now I check again and I have infinity over infinity, which is awesome. I have limit as x approaches infinity. The top prime is 2x. The denominator prime is e to the x. Again, I have infinity over infinity. I differentiate one more time. And I get 2 over e to the x, which is obviously 0. So y equals 0 is a horizontal asymptote as well. You were not asked to do that. So my failure to correctly copy infinity here, and by mistake I copied pi over 2, the whole thing collapsed. It made no sense. I mean, it made sense, but not what I wanted. Okay, so everybody gets 5 points for this, no matter what you entered, and of course for the other two. Okay, now I want to work on this problem because it was a question from before. So let's take a look. So we have natural log x equals 1 over x minus 3. So we were asked to use Newton's method and solve this equation. In order to do that, first of all, I have to plug it in. I have to move everything to one side. So natural log x minus 1 over x minus 3 equals 0. So this is our f of x. I have to be very careful here because remember the domain of this is greater than 0 and the domain of this is not 3. So wherever I'm looking for solutions, I have to look between 0 and 3, union 3, infinity. Do not waste your time to look anywhere else. I will also write the derivative here, so I have it ready. 1 over x. This is x minus 3 to negative 1. So I bring negative 1 in front, which will change this into positive. X minus 3 to negative 2. So I can write it as f prime 1 over x plus 1 over x minus 3 squared. Okay, now I need to look for an 1 unit interval. So I will plug in the graphing calculator the function first. So let me share my screen. Okay, in y equals. If you want me to record this, I can record it. But as I said, I do have a recording already posted. It's up to you. Okay, so we have 1 over x. No. We have natural log x. And we have minus 1 divided by, please don't forget parentheses, x minus 3. And then I go with second and table. And I cannot plug in 0. I'm going to plug in 1. I'm going to plug in 2. I'm going to plug in 4. I cannot plug in 3. 4. I'm going to plug in 5. I'm going to plug in 6. Okay. So I'm going to go back. So here it goes up. Let me go back to 3.1. Okay. So between 3.1 and 4. So at 3.1, because I cannot plug in 3, between 3.1 and 4, it's smaller than a 1 unit interval. At 3.1, f of 3.1 is negative, and f of 4 is positive. Okay. So now I have to state, number 1, f of x continuous on at least 3.1 comma 4. 2. F of 3.1 is less than 0. F of 4 is greater than 0. From 1 and 2, comma, by IVT, there exists a C in the open interval 3.1, comma 4, such that f of C is 0. Now, looking at the derivative, I can start at 4. 4 minus 1 is okay. 4 in the denominator is okay. So I can consider my initial value 4. So now go back to the graphing calculator. Careful how you enter it. Do not delete what you already have in there. So we have to create Newton's function. I call it Newton's function with second and insert with x and then minus parentheses all the way. And now divide by, and now I have to carefully enter the derivative. So 1 divided by x, which does not need parentheses, plus 1 divided by parentheses x minus 3, close, squared, and close again. 1 over x plus 1 over this, but everything has to be in parentheses. At this point, I call the variable. I call the variable y1. Enter. I decided to start with 4. One more thing before I continue. I just want to present the function here so you have it. So n of x equals x minus the function natural log x minus 1 over x minus 3. And the denominator, that's not clear enough. Now it is. And the denominator 1 over x plus 1 over x minus 3 squared. I hope I put the minus in there. I'm going to check. I don't know if I put the minus. Did I put the minus correctly? Yes, I did. Okay. Good. So now our first iteration will come up at this moment. Remember, we are waiting for, we're expecting an answer between 3 and 4, 3.1 and 4. So x sub 1 is 3.690964511. Then I just copy second and entry. Make sure that you overwrite just this time second and previous answer and close and enter. So x sub 2, 3.7507261187. I'm assuming 6 decimal digits. I didn't ask. Okay, so x sub 3, the third iteration, 3.755671965, and then I continue till I stop. Okay, one more. So x sub 4, this should be it. 755700865. I'm pretty sure that the next one will be identical because it's already done. But good enough. 2, 4, 6, 7, 8 decimal digits. So I don't need to copy the last one because I already have 6 decimal digits. Here they are. 2, 4, 6. Any questions on